Hello, this video presents part 2 of the Solow growth model. In this video, we're going to solve for the steady state equilibrium. We'll start with the economy's production function. Got this Cobb-Douglas production function with constant returns to scale, assumption used in the Solow growth model. The exponents sum to 1. We have a saving rate equal to 0.25, a depreciation rate of 0.1, and here we're going to solve for the steady state capital labor ratio, output per worker, investment per worker, and consumption per worker. Step 1, we're going to solve the per worker production function. We're going to take the production function and divide both the left-hand side and the right-hand side through by L. So L to the 1/2 divided by L leaves us just with L to the 1/2 power in the denominator. And now we're going to let lowercase y equal output per worker, y divided by L, and lowercase capital, or lowercase k, represent capital per worker, or the capital labor ratio. So rewriting our production function then on a per worker basis, we have y equals k to the 1/2 power. Our next step is to solve for investment, lowercase I. Investment equals saving, so where saving equals the saving rate times income. So investment equals the saving rate times income or output. And we're going to substitute into this investment equation. For y, we're going to plug in k to the 1/2 power. And for s, we're going to plug in 0.25. Making those substitutions, we have our investment function. Step 3, we're going to solve for the annual capital stock depreciation, the depreciation rate times k. So 0.1, and that's just going to be multiplied by k. In step 4, the steady state solution, the change in the capital labor ratio, or the change in capital per worker, is going to be 0. So here's the change in capital. It's investment minus depreciation. Making our substitutions for the investment, for I, we plug in 0.25 k to the 1/2 power. And we just solve for the amount of depreciation, 0.1 k. The change in capital we set equal to 0 again. And now we're going to solve this equation for k. Dividing through by 0.1. Just rewriting that last step. And simplifying the left-hand side. And now dividing through by k to the 1/2 power. Leaves us with k to the 1/2 power on the right-hand side. And now squaring both sides. This is the steady state level of capital per worker, capital labor ratio. It is 6.25. We'll plug this 6.25 back into the production function, and we'll see that output per worker in the steady state is 2.5. And investment in the steady state. Here's our investment function, which also equals the saving rate times income. So 0.25 is saving rate. We just found income at 2.5. And we have our investment per worker. And finally, consumption per worker is just going to be y minus I, and that equals 1.875. If the capital labor ratio was greater than 6.25, the change in capital would be negative, meaning depreciation exceeds investment, and capital and output will fall until the steady state is reached at the 6.25 units of capital per worker. On the other hand, if capital is less than 6.25, the capital labor ratio is less than 6.25, we'll have the opposite. Investment will exceed depreciation, so capital and output will increase until the steady state level of the capital labor ratio is reached at 6.25. All right, I'll stop here. Hope you found this video helpful.